Good morning. My name is Jack McGinnis with Citizen out of Southern California. I'm here to talk to you today about Citizen's brand new model M532 Type 8 machine. The M machine has been around since the mid-1990s. For those of you who have been around for a while, the first thing you'll notice on this machine, it's a much larger machine. I'm going to go through some general features that are different from the older machines, that are new, and then we'll get into more the concept of the machine itself. The first thing you'll notice, again, much larger machine. Machine weighs about 9,500 pounds, much larger casting, much heavier than the old machines, allowing us to get into much heavier cuts and stability for nicer finishes when we're machining components. The other first thing you'll notice right out of the gates is a much larger door to access into the machine, allowing us to hit all sides of the machine very easily. In addition to that, our new turret has now a tang drive for the live tools. Grab this in lieu of the older gear-driven heads, gear-driven tools, allowing us again to be able to drive more power into the tool, getting more aggressive cuts. The control is a new Mitsubishi 850 control. Offers us a touch screen so we can get around in different areas, depths of the control much easier. Pictures, and again, very good access for our operators, much easier to do. The M machines, as all Citizens, is a sliding headstock machines. I think most of you are familiar with the Swiss type. Our headstock in this machine has 12.5 inches of stroke, meaning I can get long, thin parts machined on this machine, and we're going to go through some of the aspects of that as well. So we have a sliding headstock, outboard. I bring you in here a little bit. We have our guide bushing, which is a support bushing. Again, we call it guide bushing. So we tighten that up around our material. And our tools off our gang block are set about 80 thousandths away from the face of that guide bushing. So we've got a very rigid setup. No deflection when I'm machining and turning. Our gang block, we can put turning tools, we can put grooving tools, knurling tools, back turning tools, cut-off tools up on this block. Now this gang block moves in what we call a Y-axis, and an up and down, and X-axis. So we virtually have, obviously, the Z-axis headstock, an X and a Y, so I can face, I can turn, do those type of operations. In addition, if I can bring you in here a little bit closer, we have X-axis live tools on this machine. We have 4 standard. So again, with my Y-axis, I could have material sticking out here. I can simply walk across a part with the live tool, creating a flat. I have full indexing on this on the headstock, so I could machine a square or a hex if I needed to. I can, in addition, with my Z-axis and my Y-axis, I can come down with an end mill, and I can G2. I can circle interpolate a boss on a part. Or if I had drilled a hole, I can go into the hole, and I can true up that hole. Really a full machining center capability up here on this machine. So I've got my stick tools, we've got our live tools, and in addition, on the gang block up here, I've got a 90-degree head with 4 live tools facing front, 4 live tools facing back. This 90-degree block has a programmable B-axis, full B-axis. I can program this to any angle. So if I had angle holes, if I had angle flats on a component, I could certainly machine that. We can actually machine, if I had a sphere, a ball's shape on the front, I could actually come down and I can machine using that angle. We virtually have a 5-axis movement we could use in the front of this machine. And we're going to show a part in a little bit using my Z-axis, my Y-axis, my X-axis, my C-axis, and using the B-axis as well, full 5-axis move. This may sound somewhat complicated. I've been with Citizen since the early 1990s. Citizen's done a very good job at this over the years. They have simplified the programming of all this. I'm not going to get into a lot of detail, but we call the front side, the axis I just spoke about, $1. If I could bring that up. My main program, $1. Richard will get more into that in a few minutes. In addition, on the M machine, we have a 10-station turret, live tooling capable on the front or on the back. We can put turning tools on this turret. We can put ID tools on this turret, facing the main or facing the back. The turret, in addition, if you wanted to load up for a family of jobs or many jobs, we have half indexing capability on this turret as well. So we have cell tool holders that have half index positions, so I could have ID tools off center, off half index, and really load this thing up if I wanted to. With all that said, this turret has its own Z-axis, a Z2, has its own X-axis, up and down, and has its own Y-axis, giving us full machining center capability on this as well with our live tools. So I talked about $1. The turret is now reprogrammed in $2. Very simply, what Citizen does, our cutoff face on our material is Z0. So we touch our tools off to the OD of the stock, and any of our ID tools off to the face of the material. The machine knows where that Z0 is. It also knows where all the tools are. So I can take this now, if I wanted to turn at, say, 4 thou per rev, and I wanted to come in here with a drill and drill at, say, 2 thou per rev. And in fact, if I wanted to peck drill while I'm drilling at 2 thou per rev, we can simply link the turret up with a 3-digit code, and it will overlap its program over the main program. You don't have to worry about where all this is. The machine knows where it is. So I could be actually turning and drilling simultaneously, and if I'm drilling slower than the feet of the turning tool, you'll actually see this turret backing up, peck drilling as we went. So again, full capability, live tooling, turning, ID work off the turret. In addition to, we're going to get a little bit more into high pressure cooling in a minute. I'll talk about that in a minute. In addition to that, we've got a subspindle, full subspindle with a C-axis also. My subspindle programs are what we call $3. So I could come in, I can grab the material, and I could actually support. If I link the subspindle up at the headstock, I can now come in and support that in movement. It will follow its program. It will follow the main program, the headstock program, and just slave it. So we support the material so it's not whipping out on us. I can then turn, I can do any machining center operations, milling, whatever I needed to do. I can then come in, move forward, grab the material with my subspindle, cut off, and I could use the tooling on the back side of the turret, ID, OD, live, or if the turret is tied up at the front, I've got an additional stations up on top here. There's 3 stations, all live tool capable. On the front here, we're showing a 90-degree live head, 3 positions. We can set that at an angle if we wanted to and do angle milling, angle drilling. We don't have a tool in our center, but I can put stick tools in here. I can put live X-axis tools in here. And in the back, we've got a 90-degree static block as well. So again, I can give you extra tooling capability on the back here, so I can separate my subspindle out and give you free time machining in the back. So this machine is actually a 12-axis machine. Again, if I take a look, Z1, XY, B, C, Z2, X2, Y2, and Z3, X3, Y3, C-axis on the back. But again, Citizen's software, the architecture, simplifies all of this. We program to each section, and machine knows where the faces, the cutoff faces are when I'm in the back spindle as well. And we've touched the tools off. The machine will take care of all those calculations for us. So that's basically how the M machine works and how we can process parts through it. I want to talk a little bit about some of the things that Citizen has done over the years to help support robust setups and operating this machine. I'm going to walk over this way, guys, if that's okay. We offer high-pressure coolant pumps. We've been making high-pressure coolant pumps from the mid-1990s. These have developed over the years. We now have 10-line pumps, 2,000 PSI. It's got its own PLC. We interface this back in through the machine control. You can turn these lines on and off through your program, making it very, very nice and simple. We can bring those high-pressure lines into different areas of the machine. Our gang blocks now support the high pressure, where we can now bring tools, put tools in, and we've got one tool company, there are many, but NTK now supplies, I don't know if you can see this, guys, take a quick look. We can put coolant right in through the tool holder itself and have high pressure coolant come out right at the cutting tip. That offers good chip control, and it offers good lubricity on the cut. So again, we're trying to control that process. So if we've looked at a component for you and we give you a 45-second cycle time, a 2.5-minute cycle time, whatever that might be, we want to control chips. We want to clear chips off of drills. We want to clear chips off of maybe our turning tools if things are getting balled up a little bit. We can do that with the high pressure. In addition to that, if I've drilled a hole in the main side, in the front side, and I come in and grab it with my subspindle, cut it off, and I've got it in the back, and I'm working the ID on the back, potentially I'm packing chips back into the subspindle, which may cause me a problem eventually to try to close that collet. So standard on the machines, we've got a pneumatic line that comes through, we blast the air through. We pull that off, we put a high pressure coolant through the subspindle. Again, now we can come in 2,000 PSI. So if I'm working the ID on the back while I'm machining, we can blow a high pressure coolant through, giving us, again, good lubricity on the cut, and also keeping that subspindle clean, keeping that collet clean. So again, we can give you a robust setup so you can machine, keep these machines running. That's the whole idea. So a lot of capability on this machine. Again, for those of you who've been around for a while, much larger, beefier, strength, more robust tooling systems. We can really get aggressive with this machine. I'm just going to walk around the machine quickly if you want to follow me through. We've got a very large coolant tank. And if you were to buy one of these machines and wanted to add a chip conveyor in the future, it's all set, ready to go. You can just add this. This will accept it. In addition to that, we have standard 2 flow pumps in the back. Again, getting good coolant, good oil in throughout the whole machine. We have that in conjunction certainly with the high pressure coolant. And a little further up, we've got 2 heat exchangers, one for each spindle. We want to keep the machine stable. Again, we've got a big casting for stability and for aggressiveness, but we want to maintain the temperature of the machine, and we can certainly do that. Citizen's done that with our heat exchangers back here. Walk back around the front. A couple other things I want to talk about, and this really relates to our entire line, not only the M machines. Citizen has done a good job over the years looking at applications and coming up with solutions. One of the things we offer are high-speed spindles, high-torque electric spindles. Again, we've been doing this for many, many years. A lot of tiny little medical parts we can get in, small little hinges and whatnot. We can get up to 60,000 or 80,000 RPM spindles. These are listed on our price sheet as if this makes sense, a standard option. So we've got them all set up. We have the interfaces all done, so we can just implement these with the tooling blocks to hold them and put them on the machine. You can buy these in the future as well on any of our machines if you have a need. The other thing that Citizen offers is what I call a convertible guide bushing. Some people might call it a chucker type style. When we put on a Swiss machine, our headstock always moves in a Z-axis, but we can pull our guide bushing out. That spindle nose will extend through. We put a little cap nut just to cover the space so we don't get coolant and chips into the back, and we can now make this really a fixed headstock machine. Again, we're still moving the headstock in Z, but now we're using a collet. That's right across our entire line. This machine, in addition, as all our machines, we can size it up. 32 millimeter machine, 1.25 inch, but we can go up to 38 millimeters simply by changing the sleeve in the main spindle, changing the guide bushing, and if you need it bigger in the sub spindle as well, we can put a larger 38 millimeter sleeve in that as well. So we can get you up to just over 1.5 inches on this machine. The other thing that Citizen has worked on and has been very popular as of late is what we call LFV, low frequency vibration. Again, we give you a process, we give you a cycle time. We want to make sure you get there. So high pressure helps us controlling chips. There's a lot of things we do that'll help you control chips. But now the LFV function actually allows us to set and come in and out of the cut a little bit. You can set the different parameters if you want to get a little bit more or less aggressive on this, and actually automatically break chips. We've sold quite a few of these in Southern California. And I had one fella come back after me. He was so impressed with what it was doing on the front on an L32 machine. He was mad we didn't have it on the back. Since then, Citizen has implemented it on the back, and we've certainly installed it on his machine. Many of our machines, a high percentage now, go out with the LFV. Again, giving you a robust process so you can run. Many of our customers want to run well into the evening and let these machines just go. We can do that. So the 38 millimeter LFV, high pressure, convertible, high speed spindles, all things that Citizen brings to the table because of needs from our customers. So if you have something you're looking at, please let us come see us, let us know. We've got a full group back east. We've also got a very good group here in Southern California that we can think out of the box a little bit and come up with some ideas that really might help you out. With that said, we're going to show a video of a part. Where am I going here? Right here. We actually have a wave on this, and this is actually going to be a 5-axis move. Not many other machines of this nature can do a 5-axis move. We're actually going to move in C, Z, X, Y, and B, keeping this tool where we need to keep it to complete that wave on this part. So with that said, Richard, you want to go to the video?
As we said, we're going to show you machining a part on the M532. First off, let's show you what it looks like when we're doing a high-speed check function, checking for any errors in the program, such as syntax or queuing code errors. We shift now over to doing a face-off move on the machine. Going to bring in two tools, an ID and OD tool simultaneously, using axis superimposition, a very powerful function of the Cincom control. Allows multiple cuts at the same time. Back tool block is turning the OD of the part, the back side. Bringing the ID tool up to the front side. While that's going on here, we'll take a look now. We'll see this notching out as a rough notch, getting ready to machine a feature later on in the program. Setting a block on the back side, a live block to drill angled holes, fairly straightforward yet simple process with the Cincom control. You are doing another roughing out. getting ready to move into the 5-axis machining mode. Drilling angled holes on a Cincom machine is a straightforward process. A couple of simple commands. Your local application engineers can show you how easy this is to do. Starting the profile with a 5-axis machining, following it around. We start doing a little rough pass first. Come back around and do a finish pass right after that. And finish that off. Now something we're able to do, the holes that were drilled at an angle on the back side, now we can come up and chamfer them utilizing the gang tool. It's on the front side, so the main side spindle. Maintain absolute positional accuracy. The back block, that B-axis block can actually rotate 45 degrees on the back side. Come back around now, we're going to do a pinch drilling and pinch milling operation. These spindles line up exactly. We're going to turn a profile of the OD now, turning it down. Part on the left side is being ejected. The subspindle picked up in the basket, dropped in the parts catcher. Continue to profile the OD. Subspindle is going to come forward to grab the part, get ready to pick off. Right here, subspindle comes forward, captures the part, cut off, and we're done.
Hello again. Let me introduce Richard Erett. He's our Service and Applications Manager out here in Southern California. Richard's been running Citizen machines in his past on the shop floor for many years. He's also been with Citizen. Doesn't look that old, but it's
18 years.
18 years, so well qualified. He's going to get into the control a little bit more.
Hello and welcome to our event. I just want to go through a few control differences with this new machine, the new 850 control, the Mitsubishi control. What really makes the new M different is going to be the touch control. You can touch between dollar signs very quickly. It's very quick to interact with this control. You can see on preparation, many of the screens are very familiar with what you're used to any version M, for that matter of fact. You're going to have more choices down here. What's going to be a little bit different here is you're going to have more choices as far as the turret. So this machine, the new M, has a tool library. The tool library quickly and easily defines tools that are associated with pockets on the turret. As you can see from the picture, is illustrating exactly what turret holder you're talking about in that location. This is twofold important because not only does it give you a visual representation of the turret holder, but it also defines positions, pockets in that tool holder, so you will no longer be required to put G50 shifts in the program as past versions. As Jack mentioned, the new turret tooling for this machine, the live tools are unique to the new M. Previous M32s, the tooling is compatible as far as static tooling and stick tooling that may be required for this machine. However, live tools is now the new tang drive that Jack showed you. As you can see with the new ID station holder, you can see all the designations for the different pockets, different tools. Whatever the tool may be, this is a standard X-Cross live tool. In this screen here, you can quickly identify the tool. You can scroll up the screen. You can scroll down the screen and identify the tool, exactly what you're working for. In MC Data, many familiar screens on this screen as any Cincom. You're going to have your material OD, your bar stock OD, your positioning point, your cutoff tool. All these are very familiar with previous generations of M. No different with this machine. Where you're going to see some differences is in here, and you're going to define your tools in here. All the tools in the library you can define quickly and accurately with no mistaking the picture for the tool that you're talking about. This screen is quickly accessed by scrolling through the pictures. You can touch on the picture and it shows you the picture of what you're using. The other benefits of this screen is, again, you have no G50 shift. The G50 shift will be put in the tool pattern for you, so you will not be required to put that into the program. As you can see, all the tool holders are defined. So for example, on this tool holder, there is no definition. If you want to use some special tooling you have, or if you do not want to use the predefined G50s in the machine, you can select this page, and this page will leave you to define the tool as you see fit in the program. So this information also holds true for the back tools. As Jack was saying, we have this back tool that is set to slant. You have a few options for this tool. It could be set to cross, it could be set to face, slant. You could set the tool to free tool if you have some undefined tool in here, and it will make it nice so you can come up with any numbers you need to set a tool. As you can see back again in Edit, what's really nice about this control, I've spent quite a bit of time on this new machine. We set up this part. By transitioning between dollar signs, transitioning and placing the cursor is very fast. So I can transition and place the cursor right here, make edits that I need, and transition right to $2, right to $3 with a simple touch of a finger to the screen and make the edits that I need. The machine is very familiar again in program check. We still have program check, high-speed check function that is standard on all Cincom machines. So as we are familiar with this function, it allows the program to be checked in the background for syntax errors, syncing errors, and various other errors that may be caught prior to actually running the machine. Everybody's pretty familiar with the high-speed check, and you have the handle function. So the handle function is the same, and it allows you to crank through the program. And especially on the M, there's a lot going on in the M. You have $3 signs, you have a lot of axes moving at the same time. So the handle function is very nice to crank through the program. We're going to have another demonstration of that shortly on the L video that's going to be coming up in the live demonstration. But I can't stress enough with the handle, it's very nice to crank through the program. You can crank through a spot into the program that may be unfamiliar or maybe becoming close to interference. You can actually crank the handle backwards, removing the tool from the interference zone, hit reset, escape out of there, and make adjustments. You can also correct the program on the fly by pressing correct, and this will allow you to make edits on the fly, minor adjustments. If you see a syntax error that you made a mistake on, maybe the decimal's in the wrong spot, maybe there's a number wrong, you can quickly and easily make adjustments as you need. So many of these screens, even though this is a brand new Model M, all the screens are very familiar. All the screens and all the tool setting functions are the same. Still sitting on the top of this Mitsubishi control is our Cincom software, making it very familiar as to any old previous M. If you ran an old previous M, M2, M3, M4, you can walk up to this machine and still make it work because all the screen functions and all the screen mannerisms are still the same, even on this very brand new machine. I really like the new touch screen and the interface because it does make transitioning between screens and the data very quick and very effortless. All the safety built into the machine as far as cranking the handle and cranking through the program make it very nice. So Citizen has, with our Cincom software, we tie the programs together, as Jack was saying, $1, $2, and $3, with our G600 codes. So with the Cincom machine and the Cincom interface, the machine excels at this. It makes a very complicated machine with multi-axis very simple to tie these different areas together with simple codes, with simple G600 codes. And as you can see, I can scroll through this program simply by swiping up on $1. I can place the cursor wherever I want. If I still want to page down with buttons, I still have buttons available that I can scroll down. And as you can see, more G600 codes, G620. And in this mode with sync display, it makes it very visual for somebody to look at the screen and quickly recognize the programming, how it looks, how it's supposed to look, and make sure that your queuing is set in the proper order. It makes it a very visual, very quick access to the program. So again, to recap with the programming, with the G600 codes, when we come out and we train very well with teaching the codes and making sure these codes interface with the machine correctly and that they're understood. So basically the codes are meant to make the machine have very specific functions at very specific times, to making the machine easy to program, than making sure the machine is doing exactly what is required by using these basic codes. As with all M's, last part programming. Last part programming is a very good function. As you know, with the Swiss machine, typically when the machine stops, it has an incomplete part in the subspindle. With last part programming, what that allows us to do, it allows us to complete one complete cycle and make one complete part. You're no longer left with an incomplete part in the subspindle. So this is the function that we use in our programming technique for programming the M, or any Cincom machine for that fact, that we can make last part programming work, and you will have a complete product at the end, making setup times faster, making it more productive, and saving money because you're allowed to set up one part and get one part done at one time, one complete product. A few more screens. Back to program check as I explained the high-speed check function. A lot of the other pages like offset are very familiar, and they're also touch interactive. You touch the offset page that you want, you can see it's highlighted, you can make your direct offset to these pages. Very simple. And all the pages here to the side, again, all touch, making it very fast, saving tremendous amount of time transitioning between pages setting up this machine. As Jack said, the new M is convertible to non-guide bushing mode standard now. The drive shaft, easily to be taken off, put back onto the machine, making the machine go into non-guide bushing mode relatively quickly, effortlessly. I just want to show you the tang drive tool again, because this is the tool that is unique to this machine, to this new M, with the tang drive. The tang drive, I was really excited about the tang drive system that came out, because with this tool in the drive station, it doesn't bleed energy anymore. It's only driving the tool that's in the pocket, that's in the active station. You don't have drivetrain wear on turning tools that are no longer being used. So you may have the turret loaded up with tooling, however, only the tool that's in the active position is the tool that's turning, saving tremendous amounts of energy and power. So the main spindle, sub-spindle in this machine are 10 horsepower. The sub-spindle, the live tools are almost 3 horsepower on this machine. So the machine has tremendous amounts of power, especially with the new tang drive. Again, it doesn't bleed energy off as other machines have, and makes it a more robust situation for turning, drilling, milling, whatever the case may be. So I think we're going to take a few moments now, and we're going to have any questions and answers that you may have. I know Jack touched on the high pressure coolant. He talked about that. If you guys have any questions, it's going to be a good time. I would like to just talk for a minute again about the high pressure coolant. As you guys are aware of, typically inside the machine, you have high pressure lines that would be sticking down from various manifolds in this area. As you can see, here's a traditional manifold that we have. It would be, you would have a line coming out here, a steel line coming out here, feeding the tools. But as you can see, the regular stick tools have no manifold coming down because they are plumbed directly through the tool block from the manifold on top. It makes a very clean interface for adding high pressure and utilizing high pressure. There is no more adjusting lines, no more lines getting in the way. You can deliver high pressure coolant accurately and directly to the tool tip without fail. Turret tooling has the capability of high pressure through the turret. There's a plunger in the turret that allows direct coolant flow to the individual tools, cutoff tool, some drilling stations, and some tooling through. So it's very neat. It's seamless. You won't even see that it's happening. It'll feed the turret. It'll feed the turret directly with high pressure coolant. And as you can see, the manifold here for the back ID block. You could plumb high pressure lines through here. You have some ports up here for allowing pressure through. It's a very nice setup, very clean. Allows very easy use of adjustment to make sure that the coolant is flowing where the coolant needs to go. So I'm really excited about this new system with the toolant. NTK was a big part of this tooling that we used on this machine to get the coolant through the tools. And again, with the pocket where you place your tool has a small hole that lines up with the hole in the gang tool block and allows, again, direct access. So that also means if you do not have a tool like that, you can still run the manifold as you have in the past to give you direct access to coolant at the tool tip, no matter what tooling you use for this machine. So we're going to go ahead and take a few moments and have time for questions and answers. It looks like we have one question.
Do you have an adaptive guide bushing for the M532?
Adaptive guide bushing. So the question is, do we have an adaptive guide bushing? As I understand, the adaptive guide bushing is under development for this machine. And if it is not currently out, it will be shortly, making the new adaptive guide bushing available for this machine. So that's a good question. So can we output the tool library basically data? So yes, so the tool data, so like any other Cincom, when you input and output the program, you'll notice at the end of the $3, there is some information there, some variables. So on this machine, yes, absolutely. All the tooling library will be output with the program attached to the end of the program, including all the tool library that is currently in this machine. So if you were to take the program out and you put the program back in the machine, all tooling library information associated with that program would go back into the library, back into preparation as with previous machines, and including this machine, it includes the entire tool library that you have selected.
Again, here at Marubeni Citizen, we've got great machines, bar none. I've been selling Citizen machines since 1992. It's a wonderful company and we've got wonderful products. But beyond that, we've got a wonderful group of support and training staff.
Thank you.
Citizen has training for life. Citizen has an absolute commitment to supporting our customers. If our customers are successful, we're going to be successful, and that's what we believe. Citizen, our 4 offices, New Jersey, New England, Chicago, and here in Southern California, we've had these classes. We just did one online. I don't know what this virus, where everything's eventually going to go, but we just did an A20 class online, which is opened up to the whole country.
Yes.
So we're going to probably get a little bit more efficient at this and continue to offer this. Also, most of our guys certainly have come off the shop floor, know how to run these machines. We know how to process parts. We like to get together with our customers, do a little round table.
Yes.
Let's help you figure out how we can better produce your parts in an effective way. We're pretty good at it. Thank you.
Thank you. So they want to get a close-up of the gang plate, so see if you can get close to this manifold up here. We have this manifold here for the live tools. Live tools here. So thank you for attending this section. I hope this has been informative, entertaining. We have learned a lot about this new M over this last year. I'm a big fan of the new M with the new control. I think it makes it very easy to set up. We'd like to thank you for attending this session. Give us a moment here and we're going to transition to the next slides. And again, thank you very much.